So we are trying to do question number 51 here. If you haven't read the question, please pause the video and go and read the question. So what is happening in the question is now the moment you see the word first, so it says here a much louder sound is first heard. So the moment you see the word first, you are destined to think that the first harmonic is formed. That's what you would think. But the issue is, if you consider the practical where we use this kind of a method to measure the speed of sound, you can see that the AR column here, the length of the AR column is gradually increased from 0 and then it is further increased, right? So because it is being increased from 0, we say that the first loud sound corresponds to the first harmonic and the second loud sound means the second harmonic. But here what is happening is quite the reverse. The length is not gradually increased. The length is not gradually increased. So this is 2.9 centimeters. This is 67.3 centimeters. The length is not gradually increased compared to this length, the length of the AR column. The length of the AR column is being decreased. Okay. The length of the AR column, is being decreased. It is not being gradually increased from 0 like here, which means that we don't know what is the harmonic that is formed in both the cases. We don't know whether it is the first harmonic or the second harmonic or the third or the fourth or the fifth or the sixth or the seventh or the eighth or the ninth. We have no idea. Okay? But what we do know is between two successive harmonics, the length increases by one loop. If you look here there is lambda by 4 in the first harmonic. Then in the second harmonic here, with the lambda by 4, another loop is added, a lambda by 2. Why? Because the condition says that at an open end there should be an antinode. An open end should have an antinode, and the closed end should have a node, and the closed end should have a node. So if we consider this and if we draw for that, okay, for that system, like this system, if you try to draw the third possible length for that system, if we try to draw the third possible length, it would have a shape where there is a lambda by 4, an antinode. Then it will have two more loops. Again, compared to this one where there is one complete loop and a half loop, here there will be another complete loop, which means that the length has increased by lambda by 2. Even if you consider here, the length has increased by lambda by 2, this much. Now we have this added to it. The length should increase because the frequency is kept constant. We are using the same tuning fork there, so the velocity remains same, the frequency remains same, so the wavelength should remain the same, which means that the only way in which the only way in which another harmonic can be formed is by changing the length and giving more space for the wave, right? So the velocity is kept, sorry, the speed is kept constant, the frequency is kept constant, which means that the wavelength remains constant, so that a possible way for many harmonics to be formed is by changing the length. So in like when we derive the equation Fn is equal to this 2n plus 1 b over 4l, you can see if the length of the tube is kept constant in those derivations, if you go through those derivations, the length of the tube is kept constant. In that case, the frequency will change with the number of loops. But in this experiment and in this question as well, the frequency is kept constant and speed is kept constant, which means that the only way for different harmonics, different number of loops to be formed is by changing the total length of the tube. Okay, so what I'm trying to say is that just like this, if you consider this question, between two successive patterns in that AR column, the length will increase or decrease by lambda by 2. If now I don't know whether, like, if you take the 2.9 centimeter scenario, so this is, it's not definitely 2.9. Okay, so if you take the 2.9 centimeter scenario, I don't know which harmonic is here, but I'm just, for explaining, I'm drawing the third harmonic. Okay, we don't know which is the harmonic, I'm just drawing it for the explanation. So let's say this is the third harmonic. Then when the length decreases, so if you look here, when the length decreases, but if the frequency is kept constant, then the value of the n should decrease. So this is the third harmonic, so the next possible one will be the second harmonic, because the length is being decreased. So let's say 67.3 centimeters. The possible pattern should be the second harmonic. Okay, so why? Because the length here, from this much length, the length has decreased this much, so the length is being decreased, but the frequency is kept constant because this is the same tuning form, which means that the only way this could happen is the n value should remain, the harmonic should remain, the nth value should decrease, which means the harmonic should decrease. So if we have the third harmonic here, then we'll have the second harmonic here. I'm not saying that here it is third, that's what I explained in the first place. We don't know what is the value of the harmonic because the length of the R column is not gradually increased from 0. Okay, so we don't know that, but just for an example, if this was the third, then this would be the second, which means that this change in length will correspond to a loop, which is lambda by 2. Okay, listen to that very carefully, which means that the change in length will correspond to a loop. Now this loop has disappeared. If you consider here and here, it's kind of the water has gone offshore and engulfed this loop. Like, you understand that? So this water has taken off this loop. This loop has kind of drowned into this water. well, poetically speaking. But what I'm trying to say is that when the change in length corresponds to one loop, okay, third to 2, so one loop is missing, and that missing loop corresponds to the change in length. If you could understand this concept, then the rest is easy. So one loop, the lambda by 2, the disappeared loop, the missing loop, is equal to 67.3 minus 2.9. So the missing loop is equal to, you can say this is 67, this is 2.9. So the missing loop corresponds to 67.3 minus 2.9. 67.3 minus 2.9, which gives you a lambda of 2 times 67.3 minus 2.9, which is 128.8 centimeters. So that's basically 129 centimeters. So now I have the lambda value, then V is equal to F lambda, frequency is the question, 330 is equal to F time 129 10 to the power minus 2. So F is equal to 330 divided by 129 times minus 2. 330 divided by 2. That gives you 255.8 hertz. 255.8 hertz. So F is equal to 256 hertz. So the answer is B. Yes, 51B.